Hello everybody, welcome back. Today we're continuing with 7.8, solving problems using quadratic models. We're looking at example 2. It says determine the 3 consecutive odd integers. If the square of the largest integer is 33 less than the sum of the squares of the 2 smaller integers, solve by graphing 2 functions and finding their intersection points. So the first thing we're going to do is we're going to let the 3 integers b. So if we have the first integer and we let that equal 2x plus 1, because let's say x is 4, if we double a number we get 8 and add 1, it makes it a odd number. Same as for an odd number for x. If the x was an odd number, let's say 3, we'd have to double 3 to get 6 and add 1 to it to get an odd number. All right. Now, since they're consecutive integers, which is important, that means the second integer is going to be 2x plus 3. And our third integer, because it has to be two more than the previous number, right? Because if 5, the next integer is 7, you have to add 2 more to it. And then the third integer will be 2x plus 5. Okay? Now some people say, well, could you add 11 here, whatever. I just added 1 first, then 3, then 5. That'll be 3 consecutive integers. All right? Now let's look at what it said. It said if the square of the largest integer, so the largest integer is going to be here. So if the square of the largest integer is 2x plus 5. The square of the largest integer is 33 less. So to make that number 33 less, I'd have to add the 33 here to this integer in order for that to work. Because if this here is 33 less than the right-hand side, so is equals the sum of the squares of the 2 smaller integers. So the sum of the squares of the 2 smaller integers, so the first integer and the second integer there. I'd have to add the 33 to make this smaller. If I subtracted 33, that would make it 33 larger. So it's the opposite of which way you want to think. Okay? And it's solved by graphing 2 functions. So once you have the function or the equation here, we have the equation. Now we're going to make 2 separate functions. We do this on our graphing technology. I'm going to do it both on Desmos and on our graphing technology. So we have y1 equal to, I'll make that equal to the left-hand side, right? So this is when we make y1 equal to the left-hand side. Okay. So y1 equal to the left-hand side of the equation. And then we make y2 y2 equal to the right-hand side of the equation. And I'll put that up there as well, just so you know. We did this in an earlier section, and this creates an intersection point, and the x value of the intersection point is going to help us find those 3 integers. All right, so this is where we go to our graphing. So I've added the 2 equations in Desmos, y1 equal to 2x plus 5 all squared plus 33. The left-hand side, y equal to bracket 2x plus 1 all squared plus 2x plus 3 all squared. And I got this graph. It is 2 parabolas, but what you want to do is you really want to adjust your window. All right, so on your calculator. So for me, My x-axis I'm going to make, you can see that you clearly only need over to about -10. Alright, and then my x max, same deal, I'm going to go to +10. So you can see the graph really opening there for us. And then there's no negative, so I'll just make it -10 because there isn't much negative y-axis, and then it goes up. It's quite high, so I'm going to go to 50, and then you can really see the intersection points there. Okay, so the intersection point is -3 and 4. The 34 and the 202 don't matter here. We're more interested in the x and the x values. All right, so I'm going to take a picture of that for our notes. So I graphed them. I found the x values that satisfy these two intersection points. So we plug those in, and again we can do that in the graphing calculator. You folks know how to do that. We've done that before. So the points of intersection are -3 and 34. Again, we're not concerned about 34, and -4 and 202. Okay? So that means, therefore, the two possible values of x are -3 and 4. Okay? So what we'll do is we'll enter those in and show that to give us what the integers are going to be. Okay? So if x equals -3, we'll plug that into our first integer. So putting a 3 in, or sorry, a -3 in for x, and that's going to equal -6 plus 1, which will equal -5. Okay? And the second integer we said was 2x plus 3. Now, I know that you could just add 2 to each of them. I understand that. But this is just me showing the work. Equals. So we put a -3 in. And folks, I understand that we know that the next integer is going to be -3, but this is just showing it. So we have -6 plus 3, which is equal to -3. And of course, I know you understand that the next integer is going to be -1. Okay, I get that. I'll steal this. It's all set up already for us. And it's plus 5, plus 5, plus 5, which gives us -1. I'm going to fix this other one here. It's no big deal. Plus 1, plus 1, plus 1. Okay, so those are the three integers. All right, so if x is equal to -3, the three integers are -5, -3, -1. Okay, and that'll satisfy that. Well, we'll see in a minute. Okay, and then we're going to do this all again with x equal to +4. So that shouldn't have been -4 up there. That should have been +4. So if x equals 4, I'm going to replace the -3 and use 4. That gives us 8. 8 plus 1 is 9. That'll give us 2 times 8 is 2 times 4 is 8. 8 plus 3 is 11. And then obviously 2 more of that would be 13. Yes, your prediction would be correct. 8 plus 5 is 13. So if x is equal to 4, the integers are 9, 11, and 13. Now let's see if that satisfies our initial equation. Right? So remember the largest integer. So we'll check the this one here and see if it works. So remember, this integer, this largest integer, ends up being -5, or sorry, ends up being -1 squared. The second largest integer, or sorry, the smallest integer is -5, and the second smallest is -3. So -1 squared is 1, -5 squared is 25, and -3 squared is 9. 1 plus 33 is 34, and 25 plus 9 is 34. So indeed it does work. So just organize this chart like we're going to verify, and this is kind of neat. When we verify, we get 34, which if you look up, that is the y value of the points of intersection, which is kind of neat. So you can predict that this one's going to be the 202, right? So we'll do the same thing here, this time using 4, right? So first integer, 2x plus 5, that would be the largest of the integers, which would be 13. And then the smaller two integers were 9 and 11. And we square 13 and we get 169. We square 9, we get 81. We square 11, we get 121. And then we add the two sides together. So the left hand side gives us 202. 81 plus 121 is 202, which again is the y value of the intersection point. So it's pretty neat. That ties it all together, really. Especially for me, I'm hoping that helps. But it's pretty neat. So there's two cases where that'll happen, where we have the square of the large integer is 33 less than the sum of the squares of the two small integers. The only thing you got to remember is you got to add that. To make this number smaller, you would have to add the 33 to that side. You know, again, you could subtract it from the right-hand side. That would work as well. I like to keep it with the left-hand side. Okay, but it doesn't make a difference. It would work either way. Okay, you just have different values here for when you verify it. But if both sides are equal, obviously those are the correct values for x that allow the integers. So the answer to the question is the three integers can be -5, -3, -1, or it can be 9, 11, and 13, which is pretty neat. All right, that's it for this video. In the next video, what we'll do is we'll go ahead to example 3, the synchronized divers question for 7.8. Thanks for watching, and we'll talk again soon.